stories on my screen. You notice that it's blue. That means it's a quiz day, which means you are going to be working to be a superstar by demonstrating your very best. And we're not going to have a lunch. Instead, we're going to get started right away. Show me thumbs up if you have your packet and you're ready to get started. Thumbs up. Jacob is ready. Gia is mostly ready. Sarajo's ready. Look at my superstar mathematicians. Okay, I'm going to put the timer on my clock. You're going to have 10 minutes to work right now. Today's problem says, Mary has 17 gummy bears. How many more does she need to have 36 gummy bears? Listen again. As you hear me, you should be thinking about how to create, what mathematicians, what important details are present in this problem, and what plan you have to solve. Mary has 17 gummy bears. How many more does she need to have 36 gummy bears? As your teachers and I are looking to see how well situated you are, when we check your work, we're going to be looking for labels, for smart plans, for your best counting. Abubakar, you're late coming back. Klaus, where are you, my love? Thank you, working the whole time. So Rajo's looking like a second grade scholar. Thomas, making sure that you're focused and ready. I should see your body on your body in your seat. Zalia, it's work time, sitting down, focusing. Zalia, I should see your pencil moving. Yerlin, this is a quiz. Right now, you should not be moving. You should be sitting down and focused. In your work, I'm going to be looking for evidence of your mathematician's plan. That means all your parts are labeled. Thomas, warning 2, you should be sitting down. Thomas, you need to sit down and focus on your assignments.
I'm unmuted.
Umo, focusing on your work, you have 6 minutes to show that you were able to solve this problem. pencil should be moving on paper. I should see your evidence of your work. Siphon, please show me what you have so far. Little closer, please. Thank you. Noelle, show me. Oh, Noelle, I just lost you. Noelle, show me your work, please. A lot closer for me, baby. A lot closer. Thank you. Sean, show me your work, please. Thank you. Kingston, show me your work, please. I can't see it, dear. Closer, please. Thank you. Jasmine, show me your work, please. A bit higher. Thank you. Mason, show me your work, please.
Ms. Perez, can I interrupt?
Yes, ma'am.
Can Mohammedan and Neftali go to speech, please? So I should see you leaving the meeting, guys. Please go to speech.
Mason, can I see your work, please? Kingston Bennett, I'm looking to see the best from you. You have 3 minutes remaining. Mason, I've asked to see your work. Mason, can you hear me? Give me a thumbs up if you can hear me. Bring it closer. Thank you. Bring your work closer so I can see it. Mason, am I looking at a paper that doesn't have any work on it? Jaden, show me your work, please. Amelia, I thank you, but right now you could have been working on a second strategy because I didn't call your name. Jaden, show me your work, please. Jaden, give me a thumbs up if you could hear me. Jaden. Jaden's advisor, please note that he's not listening. Zoe, show me your work, please. Thank you. Umu, show me your work, please. Amani, show me your work, please. Amani, you should need a equation, my love, and a second strategy. I couldn't exactly tell what you did. Leah, show me your work, please. Okay, scholars, we have about 1.5 minutes remaining. Okay. Given my time to see what you have, I'm gonna call you all back together to my work. Please put your papers down and sit facing forward. 5, 4, 3, 2. Zoe, you are fantastic. You look exactly like we would during the school day. Ibrahim Sako, you did not return. Siphon, you did not return. Zachariah, you did not return. Ibrahim Sako, return. Scholars, today you had a problem where you had to figure out this situation. Amelia, can you retell the situation to us, please?
So Mary has 17 gummy bears and she doesn't know how many does she need to go to 36 gummy bears.
Okay, let's look at Amelia's hands again. Amelia, can you show us those hands the way you explained the problem, please?
So Mary has 17 gummy bears and she doesn't know how many she needs to go to 36.
Very nice way of using your hands, Amelia. So Amelia looks something like this, scholars. She said she has 17 and she doesn't know how many she needs to go to 36. What number does this let us know our problem should begin with, Umu?
That means we should start with 17.
Absolutely, scholars. Good mathematicians, they think about what's happening in a situation and they consider what they want to know. Here, sorry, trying to see, I have, I did not, sorry, I wanted,
That's what she's.
so I wanted to show you on my screen what Amelia just told us is happening. And Amelia says, well, she has 17. What she doesn't know is how many she needs to get to 36. Umu says, well, this means we would begin with 17. 17 would be how many gummy bears we have. To get to 36 gummy bears, would we be adding or subtracting? Hudson? Hudson, I can't hear you, a little louder.
We need to put we gotta go into
Let's think of the hand movements that match this problem. Amelia, will you start in our video and show us again how our hand movements went? I'm sorry, Amelia, I forgot to unmute you. I think you can speak now. Nope. Sorry, Amelia. Okay, now, sweetheart.
Mary has 17 gummy bears. She doesn't know how many she can get. How many gummy bears can she get all the way to 36?
Fatu, Amelia is letting us know that we're starting with 17 gummy bears and trying to figure out how many we need to get to 36. In my equation, I put 17. That's the number we're starting with. To go from 17 to 36, are we going to add or subtract?
We are going to subtract.
So if you start with 17, there's an amount you can take away to go to 36?
No.
No. So what would we be doing to 17 to get to 36?
We would be adding.
Scholars, how much will we add? In this problem so far, did it share how much we would need to add? Mamadou?
We need to add 9.
Mamadou, did the problem tell you how many you need to add?
You need to
Mamadou, I can see that you are not answering the question I've asked because you are not starting in a way that matches. If we start with 17 and we're trying to get to 36, according to this problem, did it tell us how much we are adding?
No.
So what do we use to represent the idea that we don't know how many that we're adding?
Question mark?
Skyla, I'm sorry, go ahead, dear. Camille, I can't unmute you. It tells me you've touched the screen. What is the rest of my equation?
The rest of your equation is equals 36.
Everybody, take a moment to evaluate your work. Liana, focus. Does your work match this equation? Give yourself a thumbs up if you started with 17, added something, and made 36. If this is not what you did, give yourself a thumbs down. Right now, the first part to understanding any problem is understanding what is happening in the problem. We've learned that the mathematician's plan will help us figure out what we need to do. After you understood the problem to this point, you were able to choose a strategy to help you solve. Cameron, walk us through a strategy. How do we figure out how much we need from 17 to 36? Tell us what to do first.
First, you put 17 in the bubble, and then you count up to 36 to see how many more she got to make 36 gummy bears.
Scholars, count with me. We have 17 and we're going to go to 18. Go. 17, 17, 17. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. What would my next step be here, Cameron, to tell how much I need?
And then you count the circles.
Scholars, count with me. Thank you, Cameron. You can count out loud. Everybody else count with us. Ready? Go, Cameron.
18.
Well, that would be labeling from 18 to 36. How will I know how much I added?
By starting at 1.
Okay, so go ahead.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
What is our total answer, Cameron?
Our total answer is 19 gummy bears.
Scholars, evaluate Cameron's work so far. We can confirm that Cameron has the right answer. So it's not about whether this is right or wrong. It's thinking of how, Kimani, we could have made this work even easier by thinking of the conjectures that we've learned this week. Who has a different way to represent this problem, to show this problem that helped them find an answer in a different way? I'm loving the number of superstar hands in the air. JL, what did you do?
I put 10 3 10 sticks.
Why did you put 3 10 sticks?
Because it helped us how many she needs to get to 36.
So you started with 36?
And then I put 6 more. I put 6 singles.
Okay. I have represented your amount by showing how I counted them. Then what did you do?
Then I labeled.
I've labeled them for you. What was your next step?
That wasn't your strategy. You used the bubble. You should tell her.
JL, does this not match the work that you told me you did?
Tell her your work.
This is actually an interesting start. This can work. Can anybody support JL by telling us if we were to decide to start with 36, how would we still figure out how many more you would need to go from 17 to 36? Everybody take a moment to think. I'm going to call on a hand that's showing me that they're really confident and believe in themselves. Fatu looks ready. Mama, do I need the best of you? Maria says she knows what to do. Maria, why don't you start? If you were to have started at 36, but the problem is still asking you how many you need to get from 17 to 36, what might you do?
36, then
would take away, then I would take away until I got to 17.
Okay, so notice that Maria is still using the numbers from the problem. She's saying, well, I will start at the 36 and take away until I get to 17. Maria, can you support me here? How do I take away?
You should take away the 6 and take away the 10 that says 30, and then you take away 3 from the next 10, so you could get to 17.
Let's look at Maria's work. Maria and JL, thank you. Maria, superstar, you. Maria showed us that if we take away this 6, this 10, and this 3, we can make 17. So far, this is showing me 36 minus something equals 17. But I still don't know what goes into this question mark. How do we figure out what this work equals? What did we exactly take away? I'm looking for a strong, confident second grade hand to tell me what they figured out we took away. Skylar, please, I can unmute you because you may have been touching the screen. Unmute yourself. Do not touch again. How do I figure out, Skylar, what goes into this question mark?
You have to count how many you took away.
Okay, what equation might help me tell how many I took away?
Equation would go 10 plus 6 plus 3 equals 19.
Yeah, 10 plus 6 is 16. 16 plus 3 equals 19. Scholars, I'm confused by something. I need your help. When Cameron solved it, he said, well, I'm going to say 17 plus something equals 36. And he started at 17 and added, and he got 19 gummy bears. But then when JL, Maria, and Skylar worked, they showed us that you can start at 36 and take away something to make 17. Both of these scholars still got 19. What important math idea did they help highlight? Everybody think. I'm gonna unmute a couple of scholars to talk together. I'm gonna unmute Sergio, Fatumata, Cameron, Hudson. Oh, wait, hold on. One of these households is a little loud for us right now. And Klaus. Were those all boys? Okay, Fatumata, you're the queen of this. You 4 scholars are unmuted. Fatumata, Sergio, Cameron, and Klaus. Tell me about what you noticed here. Who would like to begin speaking? Cameron will go first, and Cameron, you can call on the next scholar.
I noticed that I didn't use tens, and I just put 17 in the bubble, but
Cameron,
me too.
my question was less about using tens or bubbles. The question was about how come you were able to add and get to a correct answer, but these scholars subtracted and got to the same answer. What math idea is this trying to teach us? Sergio?
What math idea is this trying to teach us is that
Back up. I keep coming up here.
It's okay for you, Sergio, to say, I'm not sure. I need help here.
I need a
That's it.
Sergio, do you need help?
yeah.
It's okay to say that. Say it. Say, I need help.
Then I need a little help.
There's a couple of you that are unmuted right now. Hudson, are you ready to think? How come we saw 2 scholars we saw a scholar add And other scholars subtract and still get to the same answer. What math idea is this trying to teach us?
This math idea that can math idea that they teach us is that you can use a subtraction and addition.
What do you mean?
I mean is that when we did this problem, Cameron used subtraction and Maria and Jadiel used subtraction.
Yeah, because we had addition and subtraction here. Amelia, what math idea are we noticing when we can see that we can solve a problem with addition and subtraction, just like Kristen said?
That when we use addition and subtraction, when we do strategies, and some of us add and some of us and some of us add, it's also okay to subtract.
Why do you think this works, Dylan?
This would work. This would work because this would work because
Do you need support?
I think I might need a little bit of help.
That works.
I'm kind of stuck.
Camille, support. How does it work? Why were we able to add and subtract?
We were able to add and subtract because we was trying to figure out what was the question mark.
Okay. Tell me more. Dylan, if ever you feel like you get a moment that you want to share, don't forget that you're still here. You can raise your hand. I'm noticing a lot of movement, but not a lot of participation. I'm wondering if I'm going to be able to declare that superstar to choose a song for us to sing to if we're not all sitting down and ready. Amelia, I need you sitting down and ready. I'm a bit disappointed with the number of hands in the air. Hands tell me that you're ready to think and you have an idea. It's not going to be right every time, but it shows me you're trying. Mathematicians make a whole lot of mistakes, but they keep on trying to great. Yeah, what do you think? What did you learn from this problem where we were able to solve it with addition and subtraction?
I learned from this power that sometimes we could use addition or subtraction.
I'm not sure if that's going to work every single time. It seems like today we are not completely sure. So instead of ending with a conjecture, we're going to end with a question. We might say here something like, I'm going to put this one onto a side, and I'm going to put the question, why were we able to use both addition and subtraction to solve? Our job as mathematicians is solve this problem. Our job as mathematicians is to, when we learn the answer to this, be able to come back and add a conjecture that helps us, that shows that we understand this idea. Up to this point, we don't. Okay, scholars, it's time for you to begin close reading.